Hello, welcome to the video lesson for lesson 2-6. This is about writing expressions and equations in algebraic form. This begins on page 23 from your notes in your binder. Here we go. Today's target is I can translate a verbal phrase into an algebraic sentence. So, you're going to be given normal words, and you will be asked to translate them to math symbols or a math sentence or equations or expressions. So what I like to call this is we are translating to Mathanese. And I know that sounds silly, but it makes it an easy way to remember what it is that we're doing. Alright, so a lot of these words you should recognize. We're going to go through a bunch of examples on page 23, and then we'll do some practice on page 24. So here we go. So the first group we're talking about is addition. Alright, so we have the sum of 6 and k. So above the word sum, I'm going to put a little plus, because that's the key word that tells me what I'm doing. And then whenever I see anything else I can turn into a symbol or anything else, I do that. Now, the sum, the addition, is actually going to go in between 6 and k. So we get 6 plus k. Now, I realize that addition is commutative, meaning you can switch the order around, but I don't want you to do that. I want you to write it in the order that the sentence says. And here's why. 8 more than a number. So we've got the number 8. More than means addition. A number is our variable. Now, more than, or less than, or some other words that we're going to see, means we're going to switch the order around. So instead of doing 8 plus n, we're actually going to do n plus 8. Okay, the next one. A number, so that's n, plus 5. And that one is just as it sounds, n plus 5. G, increased by 7. Now, increased by means addition, and then obviously 7. So we're going to do G plus 7. Alright, so far so good. Let me scooch this up a little bit. Now we're going to deal with subtraction. And this is why when I mentioned earlier about the order being correct, this is example where it needs to be. Subtraction and division are two operations where your order needs to be correct. So the difference, so since this is up a little bit high, I'm going to put it underneath. Usually I like to write it above. Difference is subtraction, 5 and x. So I'm going to do 5 minus x. The order for this stays the same, the order that the number and the variable come in. The next one. 4 less than a number. So we got 4, less than is subtraction, and then a number is n. Now, when we do less than, or more than, or greater than, we switch the order. So it's not 4 minus n, it's actually n minus 4. And that's very important because those are not the same number if you switch them around. 7 minus a number, that one's nice and easy. It's exactly the way that the sentence, the order that the sentence has in it. And then a number, so n, decreased by, so subtract 9. So we're going to do n minus 9. Okay, so far so good. Alright, if you're needing to catch up, pause the video, so I'm going to erase everything. And here we go. I'm going to move it up. Okay, so now we have some multiplication. The product, so there's our multiplication, of 9 and w. Now, we don't write 9xw. We do 9w. I would also accept if you wanted to do a dot, or if you wanted to do parentheses. I will not accept the old-fashioned multiplication symbol. 10 times a number. So this time we're going to do 10 times a number, or 10n. and then a number multiplied by 3. So n times 3. Now some of you might be saying, well, it's n dot 3. I would accept that, but if you're going to write it the way that I've been writing it, the number always goes in front of the variable. So 3n. You don't do n3 when you just put the number and the variable together. Last one is division. Okay, the quotient, so that's division, of x and 4. So I'm going to do x divided by 4. Now what you need to know is the other way to write that is x over 4. And that's how we will see these a lot in expressions. So 7 divided by a number. So I'm going to do 7 over n. Okay, so there was some practice, or some, getting some examples, I should say. So now let's take a look at the next page. Again, pause it if you need to catch up. All right, here's some important stuff. We're going to actually take sentences and we're going to write these out. So first two are just expressions. So 3 more than, so 3 more than is addition, remember, twice, so 2 times a number x. So more than, remember, just like less than means we switch the order around. So I'm going to do 2x plus 3, and that's how I want you to write it. If you did 3 plus 2x, I would be making a little note that you need to switch it around. Miss Kula has 7 less students than Miss Leo. Okay, so less means minus, and less than means we're going to switch the order. Miss Leo we're going to call x, because we don't know how many she has. So it's going to be x minus 7. All right, now we're going to actually do equations. So we're going to have equal signs. So 3 more than twice a number, which we've already done. That was up above. 3 more than is addition, which means we're switching it. 2 times the number x is. So the word is an equal sign. So equals 43. So you can write that down. Now, up here, I had this part of the equation, the 2x plus 3. So it's still the same thing, 2x plus 3. So there is your equation. Okay, now we're going to see something new and important, and this will be a way for you to earn a point on your scoreboard, maybe 2. We're going to be talking about let statements, and let me read the problem and then I will explain. So Miss Kula has 7 less students than Miss Leo. Remember that from up above. Miss Kula has 77 students. So there is our equals 77 students. Define the variable. That is going to be our let statement. In other words, you're no longer allowed to just use a variable. You have to define what it stands for. And then we're going to write an equation. So, what does our variable, usually we use x, so we're going to use it right now. So let x equal number of students, and what we don't know is the number of students that Miss Leo has. So number of students Mrs. Leo has. Alright, so we know that Mrs. Kula has 7 less than Mrs. Leo. If Mrs. Leo is x, we're going to do x minus 7, just like up above. But now we can say, well, Mrs. Kula has 77 students. So there's our equals, and it's 77. So Kula has 77. Leo has some number, and then if we subtract 7, it would be the same as Kula. So to find out what Mrs. Leo has, we would just add 7 to both sides. Alright, so we'll do another example of a let statement. Joey has 15 less Pokemon cards than his sister. Alright, so there's a less than. So we're going to reverse the order, it's subtraction. His sister Gina. Together they have 35 cards. So we're going to define the variable. And then after I do that, I'm going to write an equation. So, what do I need to know? I need to know how many cards his sister Gina has. So I'm going to let G this time. So yes, you can pick whatever your variable is. Just be careful it's not a problem that involves a variable like if we were finding area, we would use A. Don't use A in an area problem for something other than area. And we'll see some examples of what I'm talking about. So let G equal number of cards Gina has. Okay, so for this problem, we're going to be adding the two together to get 35. So we know Joey has 15 less than Gina. So Joey is going to be G minus 15. And that's going to be the number of cards Joey has. So together they have 35. So I'm going to do G plus G minus 15 equals 35. There's my equation. Here's my let statements. I had a double let statement this time because there was two things I was trying to find. Okay? So to earn a point on your scoreboard, when we meet next time, so tomorrow probably, what I'd like you to do is bring up that when we define a variable, we need a let statement. Okay, when you bring that up, or the first person in your class to do it, will help your team earn a point. All right, good luck. If you need help with this, make sure you see me or see a friend, and we will see you in math.